First of all, to start us off on the new session, I need to tell you a secret. More precisely, I'm going to tell you 3 secrets, maybe 4. The first of those secrets is the acronym for our group: Strategies for Engaging, Challenging, Retaining, and Empowering Teams of Students. So, the key word in that title for me is engaging, because what we want to talk about is ways in which we can engage our students. And we know that one of the most effective ways in which we can engage students is in projects. But projects are hard. And so our 3 secrets, our 3 big ideas, are ways to make projects better and easier. So here they are. Include design projects every single year, customize design projects to student interest and conceptual level, and simplify project implementation for the faculty. And now I'm going to hand it over to my colleagues to fill in on that.
So what we want to do is drill down into each of these a little bit. Design projects every year. I think we can anticipate maybe a little bit of pushback on that. We have some challenges, that there are constraints within our curriculum for how much time we can devote to that. We have issues with resources, facilities, how can we do all these projects? So we're looking at strategies like figuring out ways to integrate the design projects into our existing courses, establishing a network for peer support, and by say peer support, I mean faculty peer support, establishing a common platform for projects, and a student-owned platform for projects. We want to have the projects customized for the students. What this means is finding projects that are appropriate for the students, first of all for the level, for where they are, the students are conceptually, make sure that the goals for the projects are achievable and modular. And if we know students are in tracks, we can focus the projects on tracks. If we have research students, they can go into research projects, for example. So some of our strategies would again be this peer support and having an academic mentoring system. And finally, simplifying implementation for the faculty. One of our team members pointed out that faculty are not dogs, they're cats, they don't herd well. So one of the big issues we see is getting faculty buy-in, the overhead for making this common platform for projects accessible, having the faculty design specialist being an island within the home institution. And a lot of times your really good project material is now behind walls. All my project stuff's behind UC's Blackboard system, for example. So we have strategies for encouraging, through the reward system for faculty, encouraging faculty contributions. This common platform, again, is a support strategy. Having a common support infrastructure as well as the common design pieces, and again, this online community. So with that, I'll turn it over to Gunnar.
Hello, everybody. Let's see. So now let's break down. We have 2 cross-cutting things that came up multiple times. One is the peer support, and the other one is a common platform, common infrastructure. So what do we have in mind? And that's what I have only for 2 slides, just to give ideas of what are we thinking of. So one element would be an online community, right, where we can connect educators. We all have great ideas, but why are we trapped into our own institutions only? There should be something that we can reach out. I have a colleague across the river, or whichever geographic feature it is, who has a great idea. I want to tap into that, I want to integrate that. So I want to connect, we want to have a system that can connect the educators across institutions across the country. That's for getting people in contact, right? That can be a forum, that can be chats, that can be what is your interest level. Second, we would like to propose something like a project or class resource, a project or a repository where we can post projects, classes, ideas, challenges. Now in here, we have lots of information already available. The key point in there is how do we make these accessible and searchable, right? So for example, by discipline, by year, by challenge level, you name it. So we need to brainstorm about how do we make it so that we can find the right project for the right purpose. And facilitate crowd updating. One thing is, it's not gonna be static. If I design it first, somebody else will take it. We'll have an even better idea, right? How do we integrate the life cycle and how to take advantage of different expertise? Then in the same site, mentoring system. In this case right now, as faculty members, we are hired, oh, you can teach. You're a professor, right? You're just tossed into the water and you're expected to teach. There should be something more of a mentoring system that helps us doing the best practices. We had the faculty NAE fellowship already as an example. Now, one thing is, how can we do that more internally? Next thing is a common platform infrastructure. And that is probably very contentious, because again, faculties are not dogs, they want to do their own thing. So the idea here is the following: identify for your discipline a common platform that can support all sorts of experiments. It can be, if you're more robotics oriented, a robotics mouse rover. It can be a simulation for a plant, or it can be a physical platform if you're more ECE oriented. If you were to achieve that you have a common platform that is across your institution, not the whole institution, across your department, let's start small, that's a common platform across your department, then you could make it so that's applicable across your discipline that you want to teach, and so that more courses can tap into these resources. In this case, you could build common resources, common support that helps you using that platform. Benefits, obviously, reduce infrastructure overhead. Increase faculty participation, because they cannot say, oh, it's too expensive to do X, Y, Z. Now, obviously, we had this argument then, oh, my platform is better than yours. This is not a problem. If you have a faculty member who has the better platform, you already won this faculty member, already does project work, no need to argue, right? So also, from a student perspective, it's advantageous because students can learn about the topic. Don't learn about the infrastructure, learn about the topic, apply it right away. Another thing is what I'm seeing as an advantage, facilitates student-centered integration. What is the problem? My subject is the best. His subject is best, her subject is best, and so on, right? We don't agree, right? So if we have a common platform, then students can see, oh yeah, if I look at the problem from this, and that angle, oh, different views, but all integrated. So student-centered integration. If we were to make it so that students own it, it gives also a sense of ownership, right? Also, and it's with other platforms, we see that already, we can take the lab home. I can show to my parents, hey, this is the awesome thing that I've built, that blinks, that moves, that does X, Y, Z. So we're having the motivation from the friends groups of the students as well. And integrate theory and practice inside and outside the classroom. It's more universal. What I'm telling to parents usually is, watch it. We're going to tap into the students' spare time with those resources. And now we come to questions. Now we need your support. We are probably not the first ones to think about this. So probably one of you has already an idea. Oh, there's this awesome platform that does this. So what do you know? How can we facilitate building a community platform for sharing ideas, right? How can we integrate disciplines, information from other disciplines? How do we identify best practices? And again, these ideas are probably not unique. What did you hear already from them? Thank you. Passing on the torch.
What questions do you have?
In civil engineering, there is the ASE Exceed training. Have you heard of it? Yeah. I mean, we're lucky we have that model. So that, I don't know if you're familiar with it. Also, Christophe was actually my mentor. Yeah, Christophe, please mentor, do tell about this.
Delegation.
All right, wasn't ready for this, but so the Exceed teaching model is a week-long workshop where master educators essentially teach example classes and active learning strategies, and then the students, which is usually 24 professors, then have to replicate their lessons with active engaged learning and some of the cutting edge stuff. So that involves flipping classrooms, hands-on demos, in-class work with students and all that. And it's usually, they do about 50 students a year with these workshops. And it's a life-changing experience. It completely changed how I teach, and I think Chloe can agree with that. It's
good.
And it's cheap, I mean, compared to the money that you're putting out, right? You have the numbers in mind.
Oh yeah, so it's fairly cheap. ASCE spends close to about $3,000 for each faculty member to go every year, and so it's not a cost to the departments or anybody else. just ASCE itself pays to educate those faculty members, so about 50 faculty members a year. And that makes an amazing difference because it goes out to all the different universities. There's so many civil engineering faculty out there that have it. I think it's almost like 1,000 graduates by now that they've got in the programs, and then it kind of filters down as other faculty members observe how well that works.
Great, thanks.
Thank you.
Dirk Rummel at University of Colorado. So there is a community of digital learning and of sort of digital librarians. I know of one project where the PI is based at Colorado, and they have something called DLESE, D-L-E-S-E, which is about earth science, and it's a curation, so that's a system for curating examples, primarily for K-12 education on earth science. So the communities do exist. Also, in my experience in the computer science, there's a conference called SIG-CSE, the Computer Science Education Group. I think that the natural inclination of at least people in computer science and maybe academics as a whole is to assume that nobody else's material is very good and that they need to redo it. Always.
No, it doesn't exist.
Yes, well, that seems to be the case. But that also the physical face-to-face, and I think, in my experience, is incredibly valuable because even though you're trying to absorb what these different repositories or collections of assets and materials are, it's very difficult to do that without that sort of one-on-one meeting for that. So the professional organizations I hadn't heard before was doing it. That's a good idea.
Thank you.
I thought it was a very good idea, excellent idea.
There, I see you.
At the University of Maryland, we require our mechanical engineering students to purchase this little unit which contains a digital oscilloscope and a power supply and a function generator and stuff like that. So they do that in Electronics 1. Electronics 2, they're required to purchase like an Arduino. But after Electronics 1, they're taking heat transfer. And this parts kit contains a temperature sensor. So now they can use this oscilloscope and make temperature measurements and record that into their computers and something like that. Or if they're taking vibrations, they can have an actuator do some actuation motion and maybe measure some sort of strain. So I think it's a wonderful idea. We hadn't thought of applying this platform to other courses, but it's easily doable.
Thank you.
So Marissa Orr, Louisiana Tech University. I have kind of a resource and then also a question request to sort of follow up. So I'm at Louisiana Tech and we have our Living with the Lab program for our freshmen. And so it's a student-owned lab kit, an Arduino, some tools, breadboard, that sort of thing. And I've actually had a lot of interest in studying the effects of student ownership of their tools. You mentioned a lot of the advantages. But also all of our resources to go with it are available on the web, livingwiththelab.com. And so you can see basically everything, all the slides that we use for each class. And we use that Arduino through the first year, and we're working, so this is the request, so that was the resource. Now the request part is we're also working to try to integrate that more upward through the curriculum. I'm in mechanical engineering, so we kind of use it in a controls class. So I'm definitely interested to hear where you go with sort of ideas for how to make that work, kind of help everybody agree on a particular platform. Because they're programming in Arduino, and then later they're programming in MATLAB, and kind of trying to make that consistent.
So let me try that, and then you disagree. So we tried. I'm electrical computer engineering, so I'm a computer engineer, and we've tried it with one common platform first, which I did for my first 4 years of my tenure track, and I was able to convince people of 5 different courses to integrate it across the curriculum, which is awesome, but it took a lot of work. Took a lot of work. One thing which I did is I tried to create my own. Lesson learned: never do that. Way too much support, way too much effort, never ever. Take something common, and there's so much common out there. I'm not saying which one is the best platform, just use a common platform which is community supported. So then what we have in ECE, we're now using one common platform. In this case, is a Z-board. It's a board which has an ARM processor as well as an FPGA. It's very subject specific, may not really make sense for you. But what I look into is, when selecting the platform, I looked into what are the requirements across the curriculum So that how can the more advanced courses easily integrate to that? And I was making sure that all the inputs and outputs and all the processing is there. And then I have an easy thing. I don't need to convince the faculty anymore, hey, use that platform. No, I say, oh, we have these common resources. Input, output, your processing in the middle. Do you want to teach the processing in the middle? Yes, right? And that makes it easier.
I was just going to comment. Arduino is, the reason why Arduino is very, very popular is because it is the barrier on using it is significantly low. That's really the reason why. But there are other products out there that the barrier is a little bit. But the one thing that you have with a microprocessor board like the Arduino is the inputs. It has the analog inputs to it. And when you have analog inputs, just about anything can be converted into voltage. And so if you wanted to do it in your circuits class, you can look at it as though it was a voltmeter. If you wanted to look at it in, if you wanted to process signals, for example, you can put the signals in and you can process it out. So it is not only cheap, it is also easy to use, and you can interface it with just about any CAD software that you have, like MATLAB. So there are plenty of opportunities for growth for that system.